So, greetings to one and all. I am Lakshmiraj LB hereby presenting a project implementation based on the topic IoT based home automation as a part of the internship program done by MXT Technologies. Introduction. An embedded system is a combination of hardware and software designed to perform a specific task. Core components of an embedded system includes microcontroller or microprocessor, memory, ROM and RAM, input devices, output devices, power supply, communication interfaces, UART, SPI, I2C, etc., embedded software, firmware, and device drivers. IoT home automation. The main objective of the project is to provide comfort, convenience, energy efficient, and security. The working principle is devices communicate through the internet. User sends commands via smartphone or voice assistant. Microcontroller processes and controls connected appliances. Control and monitor home appliances remotely using Internet of Things, that is IoT technology. This is about embedded C, a general purpose language highly effective in specialized domains. Known for efficiency and portability, a free formatted language not strongly typed. Where is it used? Its applications include embedded software development, OS kernel development, Linux, Windows, then firmware and driver development, system software and file system development. Key takeaway: C provides low-level access necessary for direct hardware interaction. Data types, modifiers and control flow. Basic data types includes integral, char, bar, int. Then floating point includes float, double. Data type modifiers and qualifiers. Size, short, long, long. Signed, signed and unsigned. Conditional constructs, single iteration, if or if, else if, bar, else, switch case. Loops, for, while, do while. Keywords. C uses a set of reserved keywords categorized for data types, modifiers, qualifiers, decision, loops, and storage class. Operators and bit level control. Operator overview. Symbols that instruct the compiler to perform an operation, always returning a value. Operator categories include arithmetic, plus, minus, into, modulus, etc. Then relational includes equal to sign, then exclamatory equal to, then larger than and smaller than signs, etc. Then logical includes exclamatory mark, and, etc. Then assignment operation includes equal to, plus equal to, minus equal to, etc. Bitwise operators perform operations directly on the bits, that is especially on the binary numbers. Logical and, or, XOR. Shift includes left shift and right shift. Memory segments and storage classes. Program memory segments. Text segment, read only fixed size, stores the compiled program instructions. Data segment stores global and static variables divided into initialized and uninitialized BSS. Heap used for dynamic memory allocation, grows upward. Stack used for local variables, function arguments, and return addresses, grows downward. Storage classes define the scope, lifetime, and memory location of a variable. Preprocessor directives includes hash include and hash define. Hash includes header files like .h, which contain declarations for functions and macros. Hash define used to create constants or function-like macros for code substitution. Introduction to C. Invented by Bajan Stostow in 1979. Initially C with classes, a statically typed compiled general purpose case sensitive language. Supports procedural, object oriented and generic programming. It is considered as a superset of C. Core pillars of OOP: abstraction, encapsulation, inheritance and polymorphism. Key application of C++. High performance and precise control over memory bar hardware are often required. Video games, high performance financial applications, embedded and real-time software. Core pillars of C++ includes abstraction, encapsulation. Abstraction means showing only the relevant data and hiding the unnecessary details of an object from the user. Encapsulation is a process of binding data, members and functions, methods together into a single unit, the class. It is a primary way to achieve data hiding and abstraction. Example: using getter and setter methods to control access to private data members. Other pillars include inheritance and polymorphism. Inheritance: the process of creating a new class from an existing class. Parent: the derived class inherits all free features from the base class and can add its own specific features. Polymorphism means many forms, poly plus morphs. It is the ability for data or functions to be processed or represented in more than one form. Project implementation. The project title is Home Automation using Arduino and Blink application. Scope of the project. The home automation should be simulated on the PICSimlab simulator, Blink IoT mobile applications used to control the devices. Should be able to control the lights, temperature of the home, inflow and outflow of water in the water tank, which we will be discussing later. Garden lights control system, where an LDR sensor detects an ambient light levels. The data is processed by a microcontroller which adjusts brightness of the garden lights accordingly. The system is also connected to the Blink cloud and a mobile app for remote monitoring and control. Arduino Uno. Arduino Uno is an open source microcontroller board based on the processor Amiga 328P. It is designed for beginners and professionals to build electronic projects easily. The board allows interfacing of sensors, actuators and modules for automation, robotics and IoT applications. Its operating voltage is 5 volt, the logic voltage level for inputs and outputs. Input voltage recommended 7 to 12 volt via adapter or battery. Digital input-output pins. It consists of 14 pins, provide PWM output. So this is the image of the Arduino Uno board. So this is a pin diagram of the Arduino Uno board. It consists of two I2C, that is clock and data, then a ground, then digital pins, which starts from D0 and ends till D30. It also consists of UART and SPI pins. It also consists of 5 analog pins, then 2 ground additionally, then input, that is 5 volt and 3.3 volt. It supports two input range, that is 3.3 volt and 5 volt. Arduino IDE. This is a software which we use in our project. Arduino IDE provides a simple and user-friendly interface for writing, compiling and uploading code through Arduino boards. It supports programming in C and C++ with built-in functions that simplify hardware control. The IDE includes a rich collection of built-in examples to help beginners quickly learn and experiment. It features a serial monitor and a serial plotter for real-time debugging and data visualization. The library manager allows easy installation and management of libraries for various sensors and modules. The board manager helps users add support for multiple Arduino and third-party boards. PICSimlab. This is also one of the software that we use to implement our project. PICSimlab simulates PIC microcontrollers PIC16F, PIC18F. Supports virtual boards PIC Genius, Curiosity, EasyPIC. Includes peripherals like LEDs, LCDs, motors, sensors, etc. Works with MPLAB, GPSIM and SDCC. Allows real-time debugging and hardware in loop testing. Supports UART, SPI, I2C, PWM communication. Ideal for microcontroller learning and experiments. These are the overall requirements of our project, that is garden lights control, temperature control system, cooler control system, heater control system, threshold temperature control, display the volume of water in a tank, inlet valve control, outlet valve control, control the volume of water in the tank. Garden lights control. Read the LDR sensor value based on the reading from the LDR. Vary the brightness of the LED, which resembles controlling garden lights based on the availability of sunlight. So this is a block diagram of the garden lights control. It takes the value from the LDR sensor and it processes to the Arduino Uno board. And Arduino Uno board processes this information and give the output in the form of the lights. Temperature control system. The temperature control system consists of a heating resistor, an LM35 temperature sensor and a cooler, which resembles the temperature control system at home. Read the temperature from the temperature sensor LM35 and display it on the CLCD. Control the temperature of the system by turning on or off the heater and cooler through the blink IoT. So the Arduino Uno takes the input from the heater, cooler, etc. Then send notifications through the blink IoT app. The temperature is measured through a temperature sensor and CLCD is used as a display in displaying all the values that we are receiving at the Arduino Uno board. Water tank inlet and outlet valve control. Read the volume of the water in the tank through serial communication and display it on the CLCD. Control the volume of the water in the tank by controlling the inlet and outlet valve by sending the commands through serial communication. Display the volume of water in the tank on the CLCD. So this is the block diagram of the water tank inlet and outlet valve control. It includes Arduino Uno, Blink IoT app, CLCD and water tank. So the necessary informations are taken from the water tank, then it is processed into the Arduino Uno board. The necessary output is taken from the CLCD and through the Blink IoT app. Through Blink IoT app, we can also control our inputs. Blink application. Blink was designed for the Internet of Things. It can control hardware remotely. It can display sensor data. It can store data, visualize it, and do many other cool things. Create widgets on mobile Blink application button, widgets to control heater, cooler, inlet valve, and outlet valve. Gauge widgets to display temperature and volume of the water in the tank on the mobile application. Virtual serial port. This port is used to connect our serial tank to the PICSimlab. For this, we require a virtual serial port. Virtual serial port is a software-based emulation of a physical serial COM port. It allows applications that normally communicate through hardware serial ports like COM1, COM2, etc. to communicate virtually without real serial hardware. Use. Connect applications that require serial data exchange, simulate embedded devices or sensors. Redirect serial communication over USB, Bluetooth or TCP/IP. Process involved in the project. Garden lights control. Read the LDR sensor value and varies the brightness of an LED, simulating garden lights based on the available sunlight. Temperature control. Reads temperature from the LM35 sensor and display it on the CLCD and a blink gauge widget. The heater and a cooler are controlled via the Blink app. Water tank control. Reads the water volume from a serial tank, simulating a water tank via serial communication and displays it on the CLCD and a blink gauge widget. The inlet and outlet valves are controlled by sending commands through serial communication triggered by the Blink app buttons. Threshold management. Automation. The system automatically responds to certain conditions. If the temperature rises above 35 degrees Celsius while the heater is on, the heater turns off automatically and a notification is sent to the Blink app and displayed on the CLCD. When the water in the tank is full, inlet valve turns off automatically and a notification is displayed on the Blink app and CLCD. Notification bar display. The CLCD acts like a dashboard for displaying real-time events and notifications such as temperature, valve status, and threshold warnings. So these are the components that we used in our PICSimlab project. So this includes the CLCD. These are the modules in the CLCD. Then this is the LDR sensor. Then this is the LED. Then this is the Ethernet shield that we are externally connecting. Then this is actually required to view the output through the Blink app. Then temperature system. It is mainly used for the heater and cooler option. Components used in PICSimlab. So let's detail about the components used in the PICSimlab. CLCD. A character LCD used to display text or sensor readings from the microcontroller. LDR, a light dependent resistor that changes resistor based on the light intensity. As the intensity of the light decreases, the LDR as the intensity of the light varies, the brightness of the LED changes. Then Ethernet module enables the microcontroller to communicate over a network using TCP/IP. Temperature system measures and displays ambient temperature using a sensor like LM35 or DHT11. Serial time, a virtual serial time communication interface used to send or receive data through COM ports. So let's move on to the project implementation. So I am going to implement the project. I am taking the hex file from my folder. It's loaded. It has been loaded. So now let's connect this with the Blink app. I am going to turn on the inlet valve. So it displays, the project displays the home automation logo. Then this is the temperature and this is the volume of the tank. Then here I am making the inlet in on condition. Then when I switch off the inlet valve, it just closes. Then I am opening the outlet valve. So now the water gets removed. So I'm turning off the outlet now. The outlet is turned off. Then I'm going to on the cooler. So this fan rotates and it displays CLR on. CLR on means cooler on. That OTFL off, it indicates that the outlet is in off condition. When I on the inlet, it turns on. When I turn on the inflow, so it displays inflow on. So this is the LDR. When I vary this LDR module, the LED's brightness goes on changing. So this is our project implementation. Hope you understand about this. And in conclusion, using Blink IoT application and PICSlab simulator simulated home automation where LED temperature system, serial time resembles light, heater, cooler and water tank in real time. CLCD act like a dashboard used for displaying the events. Widgets from Blink IoT app like button widgets are used to control heater and cooler and inlet valve, outlet valve. Gauge widgets to display the temperature and volume of the water. So I thank all the staff members of MX3 Technologies who have provided me such an opportunity in providing internships. Thank you.